stuff because I don't think any of you actually care. By the way, I tend to talk really, really fast, so if I overrun folks, just throw shmooball at me, I'll slow down. So what's the point here? I wanted to look at a bunch of data analytics and a bunch of security analytics because people have been talking about this a lot, but I haven't seen anybody really come out and say, these work, these don't, this is what real life data looks like with these. There's just been a lot of ideas. Now, what I mean when I say security analytics is modeling user behavior, modeling computer behavior to be able to say, I think that machine is compromised because it's acting weird. I don't mean a bunch of stuff about like threat modeling or any of that. This is purely modeling systems and modeling user behavior. I will consider a system a success if it doesn't need a watch list or an IP list or a signature, but purely based on just the data in a log file. Can you say, this machine is behaving weirdly enough that it's compromised, or we think it is? Now, here's the thing. Failure is an option in this case. Some of these models are going to fail. And I'm going to deliberately talk about them because part of the point is, and part of the frustration I have seen with the security analytics stuff is no one talks about which ones work and which ones don't. Everyone tosses out ideas, and if there's an idea that's a bad idea and just doesn't work, someone needs to come out and say it. So I am. So I'm going to talk about false positive rates, talk about assumptions in the models, and in a couple of cases, even if they do fail, it will turn out that the data is actually still useful, just not necessarily in the way that the original model thought of. You're not at all seeing the slides? All right, then there's two windows open here. Thank you. Better? Oh, fuck's sake. Is it full size? You know what? Fuck. You know what? Screw it. I've got 20 minutes. I'm not going to waste time with it. So anyway, the point is, I want to be able to see, and actually, which slide am I on at this point? What does it say? DNS modeling. All right, let me go back on the. So the point is, the log file I'm looking at, the data I'm looking at, is really DNS and webmail. Those are just the logs I had available easily to me. The data you see up there is just some background on what the organization is. So it's a large enough organization that false positives are going to start to show up, that scaling problems are going to start to show up. It doesn't really matter what the actual numbers are there, just it's a big enough organization that if the models do start to fail, they're going to start to show. So let's get straight to the data. The first one I want to talk about is a DNS anomaly detection model. In this case, I saw this first on a SANS handler's diary. The idea for the model is, can you take all the DNS requests that your users make and just look at the new ones, the ones that no one's ever asked for before? And are those inherently more suspicious than any others, and are they worth investigating? Now this assumes a couple of really interesting things. First, it assumes that your attackers are using a brand new domain. If they're using something like Google or Twitter as their command and control, this will never see it. That's not necessarily a terrible assumption, it's just a fact. But it also assumes that your users are creatures of habit. It assumes that if you get a big enough data set, that you'll be able to see everywhere your users tend to go, and therefore the new stuff will be unusual and interesting. That's less of a good assumption. Now, if you just do this straight out, what you're going to see is a bunch of false positives from things like Akamai, Cloudflare, your content delivery networks, a bunch of folks doing web analytics, as well as a bunch of DNS threat lists and watch lists like Google Safe Browsing. Those will stand out really quickly, so they're pretty easy to actually filter out, but you do need to do that, because otherwise it's going to be flooded with noise. Anyway, if you do that, this is the graph you get from that. This is a graph of the new domains looked up per hour over a 12-month, or a 5-month period, I'm sorry. Now I realize you can't actually see the left or the vertical axis very well. I'll come back to what that is. This kind of looks like what you'd expect from this sort of graph. There's a big spike initially, it rolls off to a baseline, there's an interesting spike in the middle there, and then sort of settles down to a steady state of some number of new domains per hour. Now, the problem is the first line above 0 in this graph is 2,000. So in fact, what you're seeing is 2,500-ish new domains looked up every hour is the baseline. from about a 40,000 person organization. That is way too many. You're never going to really investigate that. But if you look at them, it is actually working. The theory's right, the practice is wrong, because malicious domains are actually identified in there. But they're completely swamped by noise. They're completely swamped by false positives. You can't actually use this to actually identify compromised machines. So what can you do? Well, so the next idea is to try second-level domains. So a.google.com and b.google.com both collapse down to just google.com. Understand if you do this, you're going to miss some things like your dynamic DNS providers, because all the dynamic DNS ones will just collapse down to the name of the dynamic DNS provider. And understand also the country code domains are going to make this a real mess, because like .uk is incredibly inconsistent for where they put second-level domains. The Mozilla folks have posted something really helpful to get that. They call it the effective TLD list. So if you're doing stuff like this, look for the effective TLD list. So anyway, if you do that, it looks like this. And I deliberately drew this in the same scale as the last one. So you can see it's better. And that initial spike in the middle there has gone away. Actually, I should go back to that. That initial spike in the middle is also false positive, for the record. That was a networking team member who was just experimenting with an analysis tool. So anyway, this is the SLD one. It's on the same scale as the last one. It's better, but still, that bottom line is 2,000 new domains an hour, and it's still at about 1,500 to 1,000 new domains every hour for SLDs. That's still too many. So this just doesn't do what you'd need it to. It's too full of false positives. It is, again, identifying compromised domains or malicious domains, but you can't investigate those. There's too damn many. So can you get something useful out of this despite all that? Actually, you can. One of the things that I've been doing for a little while, which is working pretty well, is using the first one, the domains looked up, as a first cut for a submission to a domain watch list. The organization I've been working with isn't really in a position to outsource their DNS to any of the malicious domain providers, and you can't really submit a couple of million requests to an external API. But if you do the cut of these are just the new domains that no one's ever looked up before, that's 10,000, 12,000. That's perfectly reasonable to submit to an external API to say, are any of these malicious? And that actually works very well, because the malicious domains are being flagged, they're just buried in noise. And so you can use the watch list provider as a filter to say, these are the ones that your users are looking up. Of those, these are the ones that are actually malicious. Also, once you've done all this scripting work to build analysis tools for new domains and new lists, you're about 3/4 of the way to having a passive DNS database. So it's a pretty small step to just finish the job and have a passive DNS database. And those are hugely useful for instant response. So the data is still useful, but not necessarily in the way that the original model thought. So, all right, your users are looking up too many domains. The assumption was wrong about them being predictable. Can you model how quickly they look up names? Can you say, this user normally looks up 5 or 6 domains a day, and when he starts looking up 20, maybe that's a threat, or maybe that's them, that their machine has been compromised. Can you model that, and does that have any security correlation to them being compromised? Now, this worked reasonably, or this assumes, again, that your users can be modeled this way, that there is a standard rate of it. And unfortunately, when you do that math, I gave them users about 30 days of a baseline to build up, here's what your usual rate is, and took a standard deviation, and I had a huge number of false positives from this. There are thousands of hits that were really just false positives entirely. I went and asked a bunch of people, what were you doing? What triggered this when you were, on this Tuesday, when you went and looked up thousands or a dozen more domains than you normally do? And usually the answer was, I'd just come back from vacation. I had a bunch of email I needed to get through, and people had forwarded me links. And again, this one didn't really flag much. So this just failed. It's an interesting idea, but it isn't actually showing anything interesting. So I'm going to shift gears at this point. I want to talk about webmail. In this case, you've all seen these. You'll see the little things in, I've seen them in Google, I've seen them in Facebook, where your account was last logged in from this ISP with this browser. And the question was, do those actually work? Do they actually have any security meaning at all? And if they do, can you, if you have the server-side logs, can you model that? Can you model the user to say, This person has just logged in from somewhere they have never logged in before, with a browser they have never logged in before. Does that correlate to that account is actually compromised, and that's an attacker who's logging into their account? Now, this assumes a couple things that are so-so assumptions. Number one, it assumes that the users have a finite set of machines that they log in with. Now, it may be a big list. They may have a phone and a tablet and a laptop and whatever else, but assumes that they have this finite list of machines, and that if they go on travel, that they bring one of those machines with them. That's a pretty big assumption, but is what it is. Once you have that, I took about a 30-day baseline for this to say, build up a 30-day baseline of here's all the ASNs they have logged in from, here is all the user agents they logged in from, and then whenever any connection came in where both of those changed at the same time, that was considered suspicious or to be investigated. The idea being if they installed a new browser but they're at home, that would be a new user agent from a known ASN, so we'd leave that one alone. Or if they updated, or if they went on vacation, they'd log in for a new ASN, but with a user agent we'd seen before. Now, again, this one failed, and it failed in really interesting ways. About 5,000 users triggered this from about a 40,000 person organization, from 1,200 ASNs. They were just all over the place. Some of them were from partner organizations, some of them were from Kinko's, some of them from Best Buy, just anywhere. So the first lesson is users will log in from any damn where. If they've got a computer, they'll use it. But the fact that it fails, and it fails this way, is actually really interesting because it says some really interesting things about your user community. So you can actually pull some success from this, the idea being that if you're having discussions about going to two-factor authentication and you're talking about like a card reader system where it's going to need a card, understand if your users are willing to log in from anywhere with any machine that's in front of them, those users are going to get locked out by that. That may be something you want to do anyway, but know that you're doing it because you're going to get blowback if you just sort of blindly say, F it, we're going to do smart cards. And 1 out of every 8 of your users is going to get locked out because of that. They're not going to be happy. So simply being able to say to your management, I know what's going to happen if we do two-factor authentication. It's going to blow up, and it's going to blow up this way, is actually really valuable. So again, this failed as a user model, but it was very useful as just I understand my user base. I understand what's happening in my user base. Also, one of the other things we did with this was focus it down much more carefully. I looked at just the VIPs of the organization, because it's a much smaller group, it triggers a lot less often, and you have some hope in hell of actually getting their travel patterns and getting some idea of when they're on travel. So you can cross-correlate this to, I had 30 hits from this person, and they're all in Germany. Was this guy on travel in Germany? And if the answer is yes, those are all fine, and you can ignore them. This is actually working pretty well. I don't actually have a false positive rate for that one because it hasn't hit really yet. All the hits I've had so far have been explainable as travel, but I'm optimistic for this one because it is pretty clearly something I, A, have enough hits where I can investigate it. I don't have 5,000 in 5 months. I have, 30. That's manageable. And also, I can cross-correlate it to something else to say, I know where this person is supposed to be, and I can't ask that of 40,000 people. I can ask it of about 130. So, lastly, building on this idea, it's a related idea to this of the travel stuff. If you have a user who's logged in from Virginia or say 1 in the afternoon, and then from Kuala Lumpur at 2 in the afternoon, is that some indication that the user's compromised? You've all probably seen it. This is the kind of thing where a hacker will just log in whenever they've got an account, and they don't know when the last time your user logs in. So I'm going to assume, or for this model's sake, the user can't travel faster than the speed of sound. Because we canceled the Concorde program, you just can't do it anymore. This assumes a couple of things. The big one it assumes is that your users aren't VPNing. Or if they are VPNing, they're VPNing to you. It also assumes that your geolocation actually works, but that's reasonable. The MaxMind ones are reasonable enough that they're usable. And again, I did the same thing for this one, take a 30-day baseline of where they're generally going, and then, I'm sorry, also, there's a couple of false positives for this. I'm sorry, the 30-day baseline thing was the previous one. Yeah. There's a couple of false positives for this one that are going to come up. The biggest one is 3G to Wi-Fi, because your 3G phones are going to show up wherever the heck the ISP decides to connect to the net. And when they go home and they flip back to Wi-Fi, it's going to immediately jump to their home location. And that's going to look like an immediate, very fast movement, according to this model. So one of the ways I filtered that out was to say, you have to move more than 500 kilometers, and also then identified a bunch of the normal wireless ISPs and just exempted those. This model actually worked surprisingly well, especially considering the 99% false positive rates I had for the others. This had about a 60% false positive rate, and it did correctly identify compromised accounts. The one that really encouraged me about this was one of the accounts that it flagged wasn't compromised, but it was a user who had given their username and password to an external service. In this case, there's something called SaneBox, where you give them your username and password, they log into your mail, and they look at how you're using it and say, you're never talking to that guy, so we're just going to delete his mail. I'm not going to be the one to say whether or not SaneBox is a legitimate service, but I do really, really want to know, as a security guy, that somebody gave their username and password to somebody else. I may choose to permit that, but I want to know that it's there. I want to know that it's happened. And this is the only one that really flagged that, because this wouldn't have triggered on any IDS signature. It is a completely legitimate login, it is a totally legitimate connection. But it's a connection that I'm not sure I want to permit. So I'm really encouraged by this one. It doesn't have a great false positive rate. It's still about 60%. But that's manageable. Again, it doesn't flag very often. It doesn't trigger very often. But it's identifying things that no one else did, which I was very encouraged by. So that's about what I've got for these. If you ask me for conclusions from this, what I say is false positives matter, and the real world is a lot messier than you see from a lot of the analytics assumptions. You look for these pretty graphs with a nice little spike. That is not what happens in reality. Real life is a lot messier than that. But there is some promise here. There is some interesting stuff here. And you can get usable data out of it, even if it isn't the perfect, I know that machine is compromised because it's just acting weird. There is still some useful stuff there. So I think I have burned through these slides really, really quickly. But that's what I got. Folks have any questions? I'm sorry? What technology stack was I using for this? So for the DNS, I was collecting that with a security onion and then pulling the bro DNS.log files in. The webmail logs were just, pulling down the web server's access logs. For the actual analysis, I was using Hadoop. I kind of deliberately didn't talk about that because I didn't want to get into the whole, holy wars about this tool versus that tool, because it doesn't actually matter. It's just, whether the analytics work or not. Yeah. Do I know of any attempts to study effectiveness of machine learning? I know a bunch of people are talking about it. And that's certainly one of the directions I want to go in the future. Like trying to cluster AD logs by this person usually behaves this way, and then they're suddenly behaving very differently. I know a lot of people are talking about it. I've heard rumors that some folks had a lot of success with that with webmail logs, that this user normally reads mail and then responds to one or two things. I haven't seen any data about it. And that kind of thing is what drove me to be really just publishing data and posting stuff. Because lots of people are saying, this works really well, but no one actually has any data. So, yeah, the credit card companies do seem pretty good about that. I don't know if this sort of thing is what they're doing. Because again, one of the things that drives me absolutely batty, no one's posting data. Yeah, back here, sorry.
So I've done a lot of similar work. I found that you can actually do similar detections. You look at the host name if you're getting that VPN connection. They're coming in from a different location with a different host name.
Oh, interesting. So he's saying he's done some similar work and you can actually get some useful stuff. That's for the compromised accounts?
Yes, compromised or sharing accounts.
Compromised shared accounts. If you look at the host name that someone connects to from a VPN, if the user normally has a fixed host name, and that host name suddenly changes. So that's interesting. Yeah, back here.
So kind of building on top of that, the 3G Wi-Fi, if you added in the user agent along with that, then you didn't necessarily need that distance because you know the host was obviously the same, and so that gives you a higher level of confidence in it and lower false positives.
Yeah, so you're saying for the 3G to Wi-Fi, if you look at the user agent and check that the user agent is consistent between the two, you could be able to lower your false positive rate. I actually did some of that, and one of the reasons I backed off it a little bit was I was concerned about spoofing of user agents. And also I had a separate reason to do the 500 kilometer limit, which was, in some cases, like if you go from Starbucks to your home, where it gets geolocated is sometimes very unusual. So the 500-kilometer limit I kind of needed anyway. It was a good excuse to do it because of the 3G to Wi-Fi. But no, you're right. You could take the user age and just make sure it's consistent between the two. I've done this side a lot. I apologize. Let me do something over here. Yeah. How did I test the 500-kilometer limit? That is a complete and utter guess. I mean, that was just my saying, I feel like that is a reasonable guess for how close things need to be for me to call it nearby. No, I hard-coded the 500-kilometer limit in the script that would flag things, but the actual number is just a swag on my part. Yeah. Have I cross-referenced the top DNS lookups with Alexa? I haven't. I mean, the ones I looked at, because I would occasionally just read it by hand just to see what they were, and some of it was just, you know, WordPress sites, random blogs. Occasionally there'd be something like Coke was starting a new advertising campaign, and you know they had a domain that they'd registered like a month beforehand or something. So I didn't see anything. I didn't do that, but it looked like fairly random stuff, really. Yeah, back here. Did I ever go back and contact the user, say, do you ever log in from somewhere like Starbucks, and then, did it notify them automatically of this sort of thing? No. Part of the challenge is with 40,000 users, I can't really go and do a mass notify like that because I'll just get lynched. And that was part of the point, was to be able to do some monitoring that was as unimpactful to the users as I could manage. And that was the reason why I only polled a couple of people for the, you know, are you looking up lots of domains thing, was I was specifically trying to do as little as possible to impact the users as little as possible, because otherwise my management gets really mad at me. Another question over here.
So when you were talking about the DNS lookups, and you were talking about doing a kind of modeling of how fast the domain
Mm-hmm.
mostly to detect the backflows,
Well, so the question was, when I was doing the DNS modeling, was I looking mostly for fast flux? And like, I was actually doing the other side of it. What I was trying to model was, how quickly does the end user look up new names? The assumption being that if a user's machine is compromised, they're going to look up names more quickly than they would normally, because they'll be looking up the command and controls and the stage 2s. So I wasn't looking at how quickly the domain changed. I was looking at how quickly the user, or whether or not the user left their normal envelope of the rate of looking up new names. Okay, I'm being told that's it, so thanks everyone.